Hello everyone, welcome back to Coders Project. Today we're going to be solving the climbing stairs problem on LeetCode. This is an essential problem for anyone preparing for coding interviews because it's going to teach you a lot about recursion or dynamic programming and the patterns in problem solving. So stick around, and by the end of this video you'll fully understand how to solve this problem effectively and why it's so important. Let's get started. You're climbing a staircase. It takes n steps to reach the top. Each time you can either climb one step or two steps. In how many distinct ways can you climb the top? So if our input n is equal to 2, our output is 2 because you can take one step at the beginning and then another step, or you can take two steps at the same time. If it is 3, you can take one step 3 times, or take one step initially and then two steps at the end, or two steps initially and one step at the end. And our constant is n is always between 1 to 45. So thinking about this, what you can notice is the total number of ways to climb n steps. It basically depends on the previous two steps. So we have a sequence over here. So if you're on step n, you can come up with you can come from step number n minus 1, which is one step before it, or you can come up two steps before it. So this gives us a recursive formula over here. So the pattern is something like our total steps. It can either have come from, we could have come from the one step previously, or we could have come from two steps. So this is like our sequence. It's somewhat similar to our Fibonacci series. Where each number is basically the sum of two preceding numbers. So we can solve this problem in multiple ways. If we can either solve it using a recursive approach, we can use the formula directly to compute the result. However, this is ineffective because it's going to recalculate the same values repeatedly. We can use dynamic programming. We can store the immediate result to avoid redundant calculations. So this is going to give us an effective solution with a big O of n time complexity. We can further optimize this. We can optimize the dynamic programming technique with a constant space also. Instead of storing an entire dynamic programming array, we can use two variables to keep track of the last two results. So this will give us a space complexity of O of n as well. So we're going to focus on this approach, and then let's get started. So the first thing what we need to do is we need to handle the edge case. If n is equal to 1, there can only be one way how we can climb the stair. So if n is equal to 1, we just return 1 directly. Alright, now what we need to do is we need to initialize our two variables for our dynamic programming. I'm going to name them as first and second. So first one is going to be 1, second is going to be 2. Basically, first is going to represent the number of ways to climb one step, and second represents the number of ways to climb two steps. And now we need to iterate from 3, third one, until whatever is our integer n. For each step, the current number of ways is basically the sum of the previous two steps, which is first plus second. And then we'll have to update our first to second, and then second to our current for the next iteration. So let's get into the loop. So for I in range 3 till n plus 1, we need to first assign our current as first plus second. And now we'll have to assign our first to second and then second to our current. Now we'll have to finally check the result and then return the final result. So basically we return second. At the end of the loop, second is basically going to hold the total number of ways to climb n steps. So we just return it. Let's go and run this code. Alright, all our test cases have passed. Now let's analyze our performance for our solution. The loop runs from 3 till n, so the time complexity is going to be O of n. We are using only two variables, first and second, and we are also using a current variable inside our loop. So our space complexity is constant, making it O of 1. This makes the solution both time efficient and space efficient. And that's it. We have solved the climbing stairs problem effectively using an optimized dynamic programming approach. If you enjoyed this video and learned something new, please give a thumbs up, subscribe to my channel, and hit the bell icon for further videos. Drop a comment below if you have any questions or you want me to cover a specific problem next. Thank you for watching. I'll see you in the next one.